All right, so this is the Canvas midterm review that is in Canvas. I'm going to show you some shortcuts and things on the calculator, Desmos, maybe even the handheld calculator, to be able to solve some of these problems, especially if you are struggling. So let's look at number one, and yours may be in a different order. So just find the questions that you are just struggling with, that you were unable to answer in Canvas. All right, if x plus 3 is a factor, what are the other factors of the polynomial? All right, so really, honestly, the quickest way to find the factor is if you just go to Desmos and you actually plug this in. So 2x cubed plus 3x squared minus 29x minus 60. All right, and you actually plug this in. I had something wrong in there. And you go to the x-axis. So here's the thing. If you see -3, then x plus 3, think opposite, is a factor. If you see -2.5, then x plus, now I want to write 2.5 as a fraction, okay? If you don't know how to write 2.5 as a fraction, you can type it in and hit it this way. So it's 5/2. All right. And then the other one right here is, what was that? 4. So x minus 4. These are all factors. This one's kind of select all the answer choices. Now, I do see x plus 3. No, I don't see x plus 3. Oh, no, that's the one they gave us. Sorry. X minus 4. So make sure you had that checked. Now, this one right here, you're not going to see this one, but here we could take the 2 and actually put out in front. 2x plus 5 is a factor. Now, you can use a series of division, synthetic or long division, to divide by this one, and then you factor what's left because you'll end up with a quadratic. But this is the quickest way to actually do it. All right, number 2, the dimensions of a rectangular prism are, what is the approximate max volume? Okay, volume of a rectangular prism is length times width times height. All right, so if I were to multiply these together like this, all right, now where's the max? Okay, let's think about a graph and the max. If I were actually to put this in, okay, x plus 6, x plus 2, and 5 minus x. All right, now the max is going to be like up. Now the problem is I can't see this. The x values are fine. You see this wrench right here? If you hit it, I need to go up on my x-axis. I mean y-axis, I'm sorry. I need to go up. So I'm going to put like -50, 50. I don't know if this is enough. This is kind of a guessing game. And it wasn't enough, but I can slide this down. There we go. So if you want to do like -100 to 100, that I think would work. So right here is my max. Now, what is the approximate max volume? So they give us a point that looks like this, 2.215 and then 96.434. Okay, now notice this. X is this, so that is our X value. Now here in the Y spot would be the volume. So our max volume is this value right here, 96.434. Make sure that when you're using a Desmos, please make sure you're using the North Carolina one. Don't just go to desmos.com because it may not be giving you the correct one. And there's a little bit different features in this one versus the other one. All right, so let's look at number 3 up here. One of the factors of this right here is x minus 1, which of the following is one of the other factors. We can sit here and we can actually just go to Desmos like I did on number 1. I will show you this. Let's go and do synthetic division so we can recall that. If I have x minus 1, 1 is going in the box. Now here I need a 0 because I'm missing x squared right there. And now we put our coefficients. Now there's a 1 right there. Then you put 0, -7, and 6. The first step is drop your 1. 1 times 1 is 1, and now we add this. That gives me 1. 1 times 1 is 1, and when we add this, I get -6. 1 times -6 is -6, so I get 0. All right, now, if this started with x cubed, I'm going to start this with x squared, and then that's x. Anywhere there's not a sign, put a plus sign. I've got a quadratic now that it's actually, I should be able to factor it. The factors of x that give me, I'm sorry, you can put x and x. Factors of -6 that give me 1. So play around with that. I know 2 and 3, one of them has to be negative. So if I do it this way, that's positive, whoops, positive 1 right there. All right, so negative 2 and positive 3. So here's my other two factors. Now, both of them don't show up here. Only x minus 2 shows up. All right. Now, again, you're going to see the x-intercepts if you were to graph it at 1, 2, and negative 3. Use the opposite. So x minus 1 is a factor, x minus 2 is a factor, and then x plus 3 is a factor. You can do that as well. Now, number 4, how many relative minimums does the graph have? Well, I don't know without graphing. So this is one of those that we can go straight to our graph on. So 3x to the 4th plus 4x squared plus 4. And when I'm looking at it, you may want to zoom out, but it looks like it just is like a U shape. So it just has this one minimum value right down there. So how many relative mins? This would be one that you just have to type in the number. It's a numeric response. In any of, or so any of the ones on Canvas, you're not actually typing in an X or anything, just a number. All right, number 5, the expression x plus 4 is a factor of what is the value of k? Now, you can do a series of synthetic division, and I'll show you that in just a second, but we can also do something called synthetic substitution. Think about what you put in the box for synthetic division, negative 4. So if I do p of negative 4 and I plug in negative 4 for x, you can actually solve this. And it says it's a factor. Well, what do you remember is the remainder? Because when you plug in this value, it comes out to be the remainder. When it's a factor, the remainder is 0. All right, so this is 16 minus 4k minus 20. Well, 16 minus 20 is actually negative 4. All right, so when I add 4 over, I get negative 4k equals 4 and divide by negative 4. So k equals negative 1. All right, so that's our value. Now, you can use synthetic division. I'll try to do it here. You can put negative 4 in the box. Double check I don't need anything. 1k, negative 20. Start off synthetic division, drop down your 1. Negative 4 times 1 is negative 4. And you would add these. So when I add it, I just get k minus 4. Now, when I multiply it, distribute. So k times negative 4 is negative 4k. Negative 4 times negative 4 is 16. And so when I add it, it's supposed to equal 0. And you'll notice when I add these together, when I add negative 20 and 16, I get negative 4, negative 4k, and it's supposed to be equal to 0. And do you see that same equation right there that we solve? And you're still going to get the same thing. You're going to get negative 1. All right, number 6 right here. What are all the solutions? Okay, when a solution, we're talking about when this equation is set equal to 0. Really, solutions, you want to find the x-intercepts here. Okay, so this is another, like, let's just go graph this. All right, make sure you know how to put everything into Desmos and graph it. All right, your teacher cannot answer those questions. All right, and so when I plug it in, I see my x-intercepts. Now, here's the thing. I see 5 and I see negative 0.5. If you don't know how to write negative 0.5, put negative 0.5 in, write it as a fraction, because guess what? They have it as negative 1/2. Now, this thing right here, where was that other one? It was this one. Okay, negative 0.1. Now, negative 0.1333. So when I go to do this, you don't see this fraction. What that is 0.333 repeating. All right, put all the 3's until you see one shows up, and it's negative 4/3. Now, another option to do is to actually just plug in like the actual answer choices they give you, like negative 1/3, and you see its decimal is this. It doesn't match the decimal that we were giving, and so forth, like negative 2/3. I can see this is negative 0.666 repeating. It's not what I saw on my graph. All right, moving right along. Let's go to our next problem, number 7. Okay, so write a prime factorization of this polynomial. All right, start off with the x-intercepts here. If negative 2 is an x-intercept, then x plus 2 is a factor. If 2 is an intercept, x minus 2 is a factor. Now, there's something special about one of them. Do you know which one? It's this one. When it bounces off the graph, it is a double root. All right. That means that x minus 2 actually happens twice, and you can put a square on it. Now, the other thing is we don't know if this has been multiplied by some value, so I'm going to put a k there and use, let's say, our y-intercept. Let's use the point 0, 4. 0 is an x, 4 is a y. So I'm going to put 4 in for y, and I'm going to put 0 in for x. And then and make sure you're using like the exact point, not anything that is rounded or anything. All right, it has to be the exact point for this to work. Okay, so here 4 equals, that's going to give me 2. This is negative 2 squared. All right, and if I actually put that in my calculator, or you may be able to figure out what that is, you get 8. And so when I solve for k, I divide by 8, and I realize k equals 1/2. So basically, I'm replacing k with 1/2. And so which one has that answer right there? It should be this one right here. Another thing you can do is just graph each one of these into Desmos and figure out what the answer is. All right, number 8. Which of the following describes the number and type of roots? Well, roots, again, you will find those on the x-axis, so our x-intercepts. All right, so I'm going to go to our graph, and I'm going to graph this, x raised to the 4th minus 625. And I don't really care how high or how low it goes. I just care about these right here. If I zoom out, I don't see any other ones. I only see 2, okay? And negative 5 and 5 are considered 2 real rational. These can be written as a fraction. Well, I didn't see any like double roots. It doesn't bounce off the graph. All right. The other 2 I can't see. So what type are they? Well, they're going to be 2 imaginary. I don't have to actually find them. All right. I just have to state that they're imaginary. So 2 real rational roots and 2 imaginary. Irrational roots are the ones you can't write as a fraction. You can see those. Those will be decimals on your graph. All right. Moving on to number 9 right here. Which of the following graphs represent an even degree function that has a negative leading coefficient? Well, the first thing I want to focus on is even degree. Even degree, and you can see 2 of the graphs right here, means the ends go in the same direction. Okay, so they're either both going to go up or they're both going to go down. All right, so this is a possibility, but this one isn't. You see one end goes up, one end goes down. So I'm going to mark that out. All right, let's see my other choices and see if I can mark anything out. Well, this one end goes down and one end goes up. So I'm going to mark that off. All right, but look at this one right here. Both ends go down. Now, the other thing it says is that it has a leading coefficient that is negative. All right, focus on the right-hand side. If it's a negative leading coefficient, then my arrow is going to go down on the right-hand side. I don't care about the left, the right-hand side. All right, so do you notice this goes up? And think about it going up to positive infinity. All right, so our leading coefficient here would be positive, not negative. So it's not this one. We want to choose this graph right here because this is going down to negative infinity. So therefore, it's a negative leading coefficient. All right. Moving on to number 10. Okay, so number 10, name the number and type of roots of this function. All right, so the same type of question. If you want to, I suggest pausing this since you've already seen one like this and see if you can get the answer. So I'm going to graph this and I'm going to put this in Desmos. Again, make sure you know how to put everything into Desmos because your teacher cannot answer that for you. And you want to focus again, roots are your x-intercepts. All right, well, this time there are 4 of them. And if you look right here, there should be 4. All right, there should be 4 because of my degree right there. And I see all 4. That means they're all real. All right, I don't have any imaginary ones this time. All right, but here, do you see how this one, we really can't write that as a fraction. That actually keeps going on the decimal, and just, it's not, no pattern or anything. So this one's irrational. Okay, this one's rational. That one's going to be irrational, and this one's rational. So here I have two rational roots and two irrational roots. By the way, imaginary roots and irrational roots come in pairs. So you're never going to see an odd number of irrational roots when we give it, or an odd number of imaginary roots. All right, number 11, the function is transformed. All right, now we're taking absolute value of x. All right, absolute value, recall, is when you hit the keyboard and here's absolute value down here. So we're taking this, and this was called an absolute value function. And I want to transform it. It says x plus 3, and then you have a minus 4 on the outside. So what's our new y-intercept? All right, so here we go. When I do that, really what it's doing is you want to put a plus 3, not an equal sign, sorry. You want to put a plus 3 right here inside that absolute value sign, and then you want to put a minus 4 on the outside. So this is our new graph, okay? If you are thinking about transformations, I will kind of review that right here for a second. If you notice, this moved down 4. Just make sure that you see -5 and 5, and you can count each box as 1. Otherwise, a lot of times when it shows you it, each box is a half if you have a full screen. But here, this went down 1, 2, 3, 4, and then left 3. Some of you can tell that by this thing right here. But our question was, what is the new y-intercept? Well, here on our graph, our new y-intercept is -1. So here I'm looking for the answer of -1. If you're looking for a point, we just saw it a second ago, but when y-intercepts, your x is 0. All right, now number 12, find g of -3 and g of 5. Remember, this is a piecewise function. We talked about this in unit 1. All right, now you can do this by hand because look, -3 is less than 5. So to find g of -3, I would plug it into the first piece, -3 into the first piece. Now notice it's 12 minus -3, which gives us 15. So this part is 15 plus. Now pay attention, there's a 3 out here, so it's going to be 3 times whatever we get g of 5 to be. All right, now 5, notice I have a 5 here and here, but I want to focus on the equal to, so it's going to go back into the top part as well. All right, so 12 minus 5 is 7, like that. So 15 plus 3 times 7, so that's 15 plus 21. All right, and we get 36 as our answer. Now, how do we get 15 and 7? Now, do recall how to plug piecewise functions into your Desmos calculator. You want to say 12 minus x, and then if you hit the shift key and the squirrely bracket like that, you can't use a parentheses or anything. It's got to be the squirrely bracket. X is less than or equal to 5. Put that inequality in. Now put the next piece in. X plus 2, do the squirrely bracket. X is greater than 5. All right, so this is what our picture looks like. It actually looks like an absolute value function. So here I wanted to find g of -3. So I go where x is -3. As long as it's not that value that you see in the inequality, you can do x equals -3. And you can find where it crossed. Did you see where we got 15? All right, well, you can see the 15 right here as well. Now, this 5 is positive 5, g of 5 is a little misleading. It is 5, 7, but here's a thing that you're going to want to do. You're going to want to say, okay, like say this blue one. Do you see how I can't get to the end and it's got an open circle and it's undefined? So therefore, the answer must be right here. Okay, so we got 7. And isn't that the value you saw right there? You just need to now plug it into the equation like we did and then solve it. All right, number 13. Okay, solve the inequality. Now, you can solve this by hand if you want. You would want to isolate, so you would add the 7 first and then divide by 3. But I'm just going to go straight to Desmos. Desmos does a great job of solving these. 3, absolute value. Please don't put D in, put X. and then minus 7. With inequalities, unlike equations, put the entire inequality in like that. Now, you want to focus on the colored region right here. Do you see that this colored region is colored all the way here from, and think of this as, even if I zoom out, this is negative infinity on this side. So it's negative infinity to this value, and if I zoom back in, that's negative 3. Okay. And then it picks back up at 1 to infinity. Now I'm writing it in interval notation, but notice this is not an interval notation. Okay. Well, what is this? This is actually, it's an or statement. Okay. When it's colored on either end, it's an or statement. And you're going to see or here. And if you notice, it's everything less than negative 3 or greater than or equal to 1. The other thing is the equal to right here, because I have these solid lines right here, is going to be equal to. But you should be able to pay attention. If that has equal to, then your answer is going to have equal to in it. All right. So I'm going to stop this video and I'm going to create a second video and do the rest of the problems. So this is part 1. We're going to have part 2 if you need to go see it.